Let's talk about adding and subtracting rational expressions. In order to add or subtract rational expressions, write them as one fraction, you have to have all of your denominators be the exact same thing, be made up of the exact same factors. Most of the time, like in this example below, that's not going to be the case starting out, so you're going to have to create a common denominator. So how do you do that? Factor all of your denominators, denominators only, then multiply all your denominators so they have the same pieces, the same factors. Whatever you multiply in the denominator of a fraction has to also be multiplied in the numerator. Now that they all have the same factors or pieces in the denominator, we can write it as one long fraction and simplify. So to simplify, you first need to distribute and combine like terms in the top, in the numerator, and then treat it like we did when we simplified rational expressions earlier. So then factor the numerator and see if it cancels with anything in the denominator. For the most part in this class, you're not going to really need to do this last step here. But be aware that it could happen, and it does happen in our second example today. Let's do an example. All right, simplify. Step 1, let me show you the steps again. Factor the denominators. So if I divide out a 2, the second piece can't be factored. So notice this first denominator has a 2, which means I need to put a 2 with my second denominator, and now they have the same 2 factors. Whatever you put in the bottom, you have to also multiply on top. That's what I mean in the second step here. All right, now I can write it as one fraction. I have a 6x from my original first numerator and a 2 times 5x in my original second numerator. And the denominator, you only write your common denominator once. So I had the 2 and the x minus 1. Simplify now. So I want to get rid of my parentheses. I want to distribute or multiply in this case. I'm going to leave the denominator as is right now. So distribute and now combine like terms. They're both x terms. I can add them together. Now, last step, factor and cancel. The top is a monomial, which means it doesn't have anything added or subtracted to it, so I can't really factor anything, but I can cancel things. Remember when we talked about canceling, we said you can write every single factor in parentheses, and you can break up the coefficient, the number, from the variable, the letters. And if we do this, you have to be able to cancel out an entire set of parentheses. So my x isn't going to cancel with my x down here, but 16 over 2, we're not going to cancel the entire set of parentheses, but when we're just dealing with coefficients like this, 16 over 2 is just 8. So we can simplify that piece. So we didn't really have to factor, but we could cancel, and we ended up with an 8 with the x on top, and in the denominator, just x minus 1. Let's do another example. Okay, factor the denominators. Notice they both have an x plus 3 in common. This first denominator has a 3 also, so I need to put a 3 here. Whatever you put in the bottom, you also put in the top. This second denominator has an x also, so I need to multiply by an x. Here, whatever you multiply in the denominator, also multiply in the numerator. Now they both have a 3, an x, and an x plus 3. I can write this as one fraction. You only write the common denominator once. Let's simplify. That means multiply or distribute on the top. Combine like terms if you have them, and then factor and cancel. So if I factor the numerator, I can pull out a 2 or divide out a 2. and cancel now. I have an x plus 3 on top and an x plus 3 in the denominator. 2/3 doesn't simplify any further, so this is going to be 2 over 3x. This is a really good example to show you every single step that would happen if you have a more difficult problem. For the most part, though, you're going to have a little bit more basic problems to practice, like C and D. So in C, you're going to have to use the tricks we talked about in the past. So I can't factor the denominator, I can't factor this denominator, but notice that they're almost the exact same thing, except some things are switched around and their signs are opposite. So remember that trick we talked about before? Remember these tricks we talked about before? How you can rearrange and switch the order of these as long as you keep the signs with them, or how you can divide out a negative, which means you would change all of the signs in here. We're going to do that. We're going to rearrange this second denominator. And now it's almost the same as the first denominator. Let's divide out a -1, which means we will switch all of the signs inside my parentheses. Okay, so now it's factored, kind of. The denominators have almost the same thing, except the second denominator also has this -1, which means that we need to put a -1 in the first denominator. Whatever you put in the denominator, you have to also put in the numerator. Now they both have a -1 and a 2x minus 3. We can write it as one fraction, multiply in the numerator, combine like terms in the numerator, and factor and cancel if possible. I will accept this as your final answer, but it's written a little bit weirdly. A lot of times people have trouble with negatives, and I want you to know that putting the negative on top is the same thing as putting the negative on bottom, is the same thing as putting a negative just out front. So it doesn't really matter where you put your negative sign. This is written oddly, so I'm going to move my negative sign to the top with the 3. And then 1 times everything is just the original numbers. So this is probably what you should input into your homework system, and this is the more normal way of writing it, even though this is okay for me too. Just know all I did was decide to put my negative sign up here with my 3, and then having a 1 out front doesn't do anything. It's just wasting lead. So, final answer. Do not cancel the 3's because this is a -3. It's not times, so I can't cancel it. And let's do one last example. This is a subtraction problem. The main thing I want you to know about subtraction problems is distribute the subtraction sign to everything in the second numerator, and now it's an addition problem. So distribute that negative sign to both pieces here, and now it's an addition problem, and that way you won't get your signs mixed up, hopefully, throughout the rest of the problem. So do that first. All right, now we're going to treat it just like a normal addition problem. So factor the denominators. They're both monomials, so we don't really have anything to factor. But this first one has a 4, which means I also need a 4 here. Whatever you put in the denominator, you need to also multiply in the numerator, to both pieces in the numerator. This second one has a 3, so I need to multiply a 3. Whatever you put in the denominator, also put in the numerator. This second one also has x to the 5th versus x cubed, so that means I need an x squared here. Remember, you would add your exponents together to get x to the 5th. So now in the denominator, 3 times 4, I have 12x to the 5th power. 4 times 3, 12x to the 5th power. Same thing. The only reason I multiplied them out is because they are coefficients. Whenever you just have numbers hanging out, you might as well multiply them together so you don't waste your ink. All right, in the numerator, we have our 3x squared times 3 plus 4 times negative 4x minus 1. All right, let's multiply everything out. So multiply this together and distribute your 4. Factor your numerator if you can to see if it cancels with anything in the denominator. And since I don't have any monomials in the top to cancel with my monomial in the denominator, nothing's going to cancel here. So you can leave it like this, or if you wanted to leave it back where it was multiplied out in standard form, that's okay too.